The lecture this evening will be presented by Dr. Andres Ferreyra. He currently serves as the Industry Data Standards and Collaboration Systems Lead at Syngenta. In that role, he works globally to advance interoperability across agriculture and food systems. In order to better promote global standardization, he chairs ISO Technical Committee 347, Data-Driven Agri-Food Systems, and he previously co-chaired ISO's Strategic Advisory Group on Smart Farming. Dr. Ferreyra has a bachelor's degree in electrical and electronic engineering from the National University of Cordoba in Argentina. His Master's of Science in Agrometrology is also from there. He received his PhD in Agricultural and Biological Engineering with a minor in Computer Science from the University of Florida. Dr. Ferreyra is dedicated to enabling more profitable, sustainable, and regulation-compliant agri-food systems. He wants them to be driven by He wants it to be data-driven, principled, with multi-objective decision-making throughout the data. This evening, he will share that vision with us. Andres? Thank you.
Can you hear me now? Is it good in the back? All right. Okay. Let me turn on a stopwatch here so I can see what I'm doing. And to find my clicker. Okay, thank you all for being here. Thank you very much, Rusty and John Deere and the ATEC organizers for having me. This is a topic I've been working on for the past 15 years. And I want to share a little bit about the journey. First of all, this is me. As Rusty said, I'm originally from Argentina. I moved to Florida in 1999. I live in West Kentucky now. Originally an electric and electronic engineer, then got a master's in agrometeorology and my PhD at UF. I care with a sense of urgency you'll perceive about people, about what they eat, the food they grow, what the food means for them in their cultural context, and if they and their kids can make that continue to work. I also like to cook. And I keep bees, which is a little masochistic as well. If I've learned anything about bees is that they will do what they want, not what you want. Over time, I started with industrial automation. So early in my career, I was mucking around with pick and place machines and fancy soldering equipment and making digital designs. Got to work with remote sensing back when if you wanted to do something with satellite images, you had to get them yourself. So dating myself quite a bit here. Then I started kind of, when I got into my agrometeorology program, it was because the folks that we had made a center for remote sensing imagery asked if we could come up with some agricultural applications. After we've done things with forest fires and so forth, I didn't really know very much about agriculture at all at that time. So I took this master's, and it was fantastic because it involved soil science, crop physiology, meteorology, soil-plant atmosphere interactions, and so forth. So turns out engineers get plants if you pay attention. And so for a few years, I kind of presented as a crop ecophysiologist. And I moved to the US. Then when I finished my PhD, I ended up working for a small company called Ag Connections. And the story of how I ended up there is long. I will spare you the details. Just let it be known that these guys had this fantastic vision about a data-driven future of agriculture. And my PhD advisor, Jim Jones in Florida, was sort of smitten by that concept and the vision that they had. In Ag Connections, I started working with farm management information systems, so helping growers solve business problems. And also did things like spatial combinatorial optimization and in irrigation and so forth. Along the way, started working with interoperability of machine data, trying to bring in machine data and later IoT data into a system in the way that ultimately it could be manufacturer agnostic. Right? First, trying to bring in data so that we could start populating farm records, and then got greedier and wanted to make them manufacturer agnostic. Around 2010, our friends at John Deere pointed out that there were two organizations, one AEF and the other Ag Gateway, that we would want to get involved with because they said that we could be impactful and that it would also be valuable to us. And it was, to the point where in 2017, 2016, we were bought by Syngenta, our biggest customer at the time. I moved to a global role, and a little later on, I started working on managing large data assimilation infrastructure and some machine learning projects as well. Over the last 5 years or so, I've been very involved with ISO standardization efforts. I've focused on practical problems like the ones that I mentioned. And we're especially going to focus on this business of helping farmers solve practical business problems. Spoiler alert, data interoperability is becoming a bigger and bigger obstacle to making these things happen. Now let's talk about Ag Connections for a little bit. There we provided farmers with farm management software that allowed them to do some very practical things. Like answer, am I making or losing money in this field? Should I keep renting this field? Can I afford a rent increase? Am I being billed properly by my retailer for these products? In the middle of the season, you know, in the fog of war, all kinds of stuff happens. You can get billed twice rather easily. Am I applying chemicals by the label, or am I about to get in trouble? And also reporting with regulatory agencies and with business partners like processors. We had to aggregate selected data from different farmers that we could share, and to summarize their use of certain kinds of products, compare it to program thresholds, and then aggregate that over different geographic regions. This was part of a program, a grower-facing program that Syngenta had called AgriEdge, that still lives to this day, and it moved quite a lot of money, and it involved making sure that any given grower was meeting the levels that corresponded to whatever tier of the program they were in. We also created a powerful handheld data entry platform, and we were able to bring in data from John Deere equipment to fill in blanks of what was happening in the field back in 2007, so way before it was cool, okay? Why did this work? We were very strict in maintaining our reference data. So we had a master list of products. Each one of those products had a formally laid out formulation with different active ingredients. We had controlled vocabulary of active ingredients. Users who needed a product that wasn't on the list had to request them. And then they'd explain to our support people what it is that was missing, and the support guys would go and find it with the manufacturer and then put it into master list. People would not just get to input products themselves. We were very strict with the grower-specific instance data, with the master data of their farms and field boundaries and so forth, with unique identifiers for everything. And when something was coming in from a machine or from some other system that wasn't recognized, like a product with some identifier that wasn't recognized, you had to resolve it, translate it into something that the system could understand before you let it come into the circle of trust, so to speak. Mass balance was king. We made sure that the area treated times the rate was always equal to the total product. We enabled sending reference and master data out to machines when those machines allowed it. So we enabled recognizing things that were coming back from the field. And we invested very heavily on a very skilled and very friendly support team that managed the reference data and helped people solve their problems. We worked very hard to keep the system simple and focused on fundamentals. And a very important part is that we were able to do this typically as part of a product plus offering. So had a large manufacturer like Syngenta that instead of spending marketing budget on maybe advertising, was instead spending that money on technology to help the grower run their business better and introducing barriers to change that way, right? So it's very hard to do this when you're just trying to pay the bill 100% from whatever you're trying to charge people. And we'll discuss why in a moment. So this is the excitement part, right? I said excitement, horror, and hope, right? So this was the excitement part. This stuff worked, okay? But farm management information systems start failing at some point. Why is that? Well, you've seen these scales at the doctor, right? Where they're asking how much something hurts. Well, you know, there's always the unmet expectation of frictionless experience, right? People are like, oh, this is just supposed to work. You know, plug and play, right? No. It's hard. And people realize that they don't have time for this, right? I don't have time for this stuff, right? The most frequently used words in agriculture. I don't have time for this stuff. And there's a little asterisk there that we'll get back to in a moment. Importing data from machines is hard. Desire for quick user-created entities. You're out there in the field, you don't have this product, you say, hey, I can't enter it, you know, why can't I create that product? Because it's a death trap the moment that you start creating stuff out of the blue, right? The equipment is rarely calibrated well enough for the numbers to make sense, in part for the reason of that red asterisk up there. And workflows that match scale data. So if you go and you pick up the weight of your truck and so forth with scales and try to calibrate your yield monitor data with that, those workflows never work very well. Also, exchanging data with business partners is very painful. There's no standard data package for the different processors, and when you are trying to get GAP certified and when you're sending stuff to the FSA or to the RMA, everybody has their own requirements. Everybody has their own formats. Everybody has their code lists, right? So reporting becomes a huge burden, and you're up there screaming at, you know, number 10 in the pain scale. Now, it's often the case, and that's a little red asterisk, that people conclude that they don't have time for this because the value of the process isn't clear, right? You say, how can the value of this possibly exceed the pain and suffering, right? Well, it's important. The value of doing this well, right, is unclear. And we'll get back to this in a moment. Now, that was then, several years ago. But farming's getting harder since then, right? I like to think of agricultural production as the result of a long sequence of decisions that you have to make over the course of a season and then spilling into the next one and the next one. Those decisions are complex. The whole system is very complex regardless of your farm size. And if you're a smallholder, that is even worse because you're so vulnerable, right? In the past, a lot of these decisions were driven by local customs, what mom and dad and grandpa used to do. And now increasingly, since everything's changing so quickly, these decisions have to be driven by data. Randy set me up perfectly earlier today with his presentation because he showed us all these possibilities, right? All this stuff that's coming that we can work with. Soil data, field documentation, better agronomy. You've got all these sensors and cameras and we've got all these deliverables and we're seeing everything getting increasingly sophisticated, right? And it was awesome, right? And we can do this stuff too. But this is happening in the context where you have to exchange data with all these people. And again, everybody has their own format, everybody has their own code list, right? Your advisor and you have different farm management information systems, et cetera, et cetera, et cetera, right? It's kind of madness, right? And you have to exchange data with these people, but it's always full of friction, right? But now it gets worse because farmers have to do more than before because back in the days of Ag Connections, we were tackling fundamental questions like, this guy wants to know what I did, or I want to know if I can afford, a rent increase, or I want to know how much grain I've got in my bin so that I can know if I can respond to this market opportunity. And answering those questions is necessary, but it's not sufficient because now farmers operate under a diminishing supply of crop inputs. In practice, diminishing. Maybe you can get all the fertilizer you want if you are willing to pay through the nose for it. There's climate and supply chain disruptions. There's labor shortages. And agri-food systems are not an aspirational career choice for youth. Like present company excluded are, sharpest minds worldwide rarely say, oh, I want to get into agriculture when people ask them, what do you want to do when you grow up, right? So the combination of all of this stuff is the, horror part of the talk, right? So let's talk about TC347 for a bit. I mentioned all that friction and communication. I mentioned that desire to enable growers to take multiple sources of data and produce value from it, right? But if you've got all these different sources of data, let's make those be the yellow circles, right? And then you've got somebody trying to consume it. Let's make that be the blue circle. Then you have to communicate, and each one of those yellow circles has their own language. So you have to translate that into some common understanding for the consumer, the blue circle. And the burden of that, of making those conversions, usually falls on the consumer, right? And that turns into a very painful thing. It doesn't scale well. It becomes an unsustainable burden. Believe me, I've lived in that space for a long time, right? What's the alternative? When you communicate using standardized formats and standardized semantics, then the burden is spread evenly, It's shared by the different actors in the system. And then it is not anywhere near as overwhelming. So let's talk about ISO a little bit, which has been mentioned today a few times. It's International Organization for Standardization. The members are national standards bodies. So it's got like 175 members right now. Each one corresponds to the national standards body of a country, like ANSI in the case of the US or DIN in the case of Germany. ISO has technical committees and subcommittees where standardization work takes place. We've mentioned TC 347, it's one of the newer committees. When they're created, the different NSBs decide whether they want to join or not, and over time they leave, they join, et cetera, so membership moves over time. They typically designate a standards development organization, or SDO, to represent them in this technical committee. In the case of TC 347 and most agriculture-related standardization efforts, that organization is ASABE, right? And it establishes a national mirror committee, or a US tag, as ANSI calls them. These mirror committees designate experts to do the work, and they manage the experts' contributions because each country usually has one vote when you come down to the big ballots, like whether a standard is approved or not. How are these standards used? Well, industry use is typically voluntary, but regulators in many countries often base their work on international standards like ISO, with the idea that if something is compliant with the standard, then it is assumed to be compliant with the law. Okay, so there's important incentives for participating in these things. Now, our industry's in a bind, right? We just don't have the standards we need yet to be able to interoperate with Agrifood systems data the way that we need to. And this is because our industry and its standardization efforts and what little attention has been paid to data so far have just sort of grown in a bottom-up way. But the burden of data interoperability across the whole industry is so big that that bottom-up approach doesn't cut it. So ISO, a few years ago, back in 2021, decided that they wanted to be part of the solution. And they started a strategic advisory group for smart farming that was meant to look inward into ISO, look at its corpus of like 25,000 standards and see what was relevant, what could help with data interoperability in agriculture, what was missing, and what could be a strategy to make all of this work. The group came up with 49 recommendations, one of which was the creation of a new technical committee to house standardization work in this space, and that is now TC 347. We've got 48 members, 48-member national standards bodies, several hundreds of people at this point. Several regions are still underrepresented, but we have a very active stakeholder engagement process. We have a strategy. That thing on the right, that stack of colored boxes, is our strategy map, organized like following the balanced scorecard method for strategic management. It's got these 4 layers. The one at the bottom has to do with learning and growth, then the internal processes of the committee, then the big one above that has to do with foundational standards to make things work, and the layer on the top is more aspirational standards or ideas like having resilient and sustainable agri-food systems and so forth. Our early strategy, so the first steps we're taking in that direction, can be imagined as this little pyramid. with 4 tiers. The one on the bottom is about agreeing on what things mean. The semantics, the reference data, the code lists for crops and for field operations and for active ingredients and for products and things like that, and whatever additional data you need to make sense of those things. Above it, agreeing on the resources involved. So if you think about a task that you're doing out in the field as something that you allocate resources to, which is the way that the sort of isobus approach thinks about it. You're allocating people, you're allocating land, you're allocating products, you're allocating equipment to this thing that you're going to do out in the field. So the master data deals with that. Field boundaries are also a very important aspect of it. Agreeing on how things happen. So the observing what's happening in the field, the recommendations for what to do, the process of deciding what we're going to do about it, then recording what was actually done. And on top of that, the inference part, the actual creating value out of all of this, right? Agreeing on how we use what we know. There, I just note some of the groups within the committee that are working on each part of this pyramid. An important part of this is that we're working in collaboration with different committees within ISO, so we're not trying to be an island at all. One of those is TC23 Subcommittee 19, which is agricultural electronics. They have a classic standard, ISO 11783, that governs the way that different pieces of agricultural machinery talk to one another and work together inside a controller area network, and how they talk to farm management information systems. Another one is the 7673 series. We've got a series of ad hoc groups right now where work begins in the committee. I won't go into a lot of detail there at all. Just suffice to say that there's several of these that are very relevant to people who have an interest in machinery. So the reference data one, the one on annotating agri-food data for artificial intelligence, for example, or digital representation of field boundaries. One that I'm especially interested in drawing your attention to is ad hoc group 7, that has to do with the top of that pyramid, right? And we'll look into that in a moment, a little further. The 2 blue arrows have to do with the first 2 groups that have already produced drafts that are on their way to becoming international standards 2 years after we got started. So let's do some examples or a little bit of elaboration on each one of the levels of this pyramid, okay? So the lowest part, reference data, semantic resources. That was on agreeing on what things mean, okay? So first, there's some ways of doing business in ag that are starting to not work anymore. The part where you'd go to the retailer and they'd sell you a couple jugs of a chemical, pat you in the back, wave you goodbye with a smile. That doesn't quite work anymore, because you can get into a lot of trouble if you can't manage the complexity that comes with that label, that comes with those jugs, right? So a jug doesn't exist in a vacuum. It comes with a little book that might have, 100 pages, a very small type that tells you how you can use or can't use that product, right? And it can be quite complex. We can't disengage ourselves from how the customers use them, because that can have environmental and social damage as a result. So instead, input and equipment manufacturers are increasingly invested in helping our users use the products effectively and safely and on target. It helps everybody, and it keeps those active ingredients available for the use that they were designed for. So let's go into a use case real quick. Active ingredient load. So product labels usually include an annual upper limit on how much of this active ingredient you can apply per unit area, say glyphosate or something like that. It'll say you can put so many grams of this per acre or per hectare maximum per year. And so then you go and you're going to mix a tank with these things and you're going to go apply it. What would we want in light of what we said in the previous slide? We'd want there to be a warning if this thing that I'm planning, this application that I'm planning, will exceed the active ingredient load that is allowed for any of the active ingredients involved, right? Translating this into data means you have to keep track of every product application over the course of the year, all the ones you had before now, and then see what happens if you add this one that you're planning. You have to record the concentration of the products in the tank mix. So how much stuff did I add to the tank? Keep track of how big that tank is, how much you're filling it. Calculate the amount of each product per unit area, right? Across all those applications. Calculate the amount of each active ingredient, then add them up across product and applications, compare against the thresholds, and then warn the user if they're about to make a mistake. And you want, again, to do this when you're planning the application so that you can help them prevent a problem, right? In terms of data management, you have to strictly manage your product identity. You have to strictly manage your product formulations. You have to strictly manage the identity of the active ingredients so that the same active ingredient across different products, is still counted as the same active ingredient. You need to keep track of your units of measure, and you need to have geographically accurate application records. That's a lot. Now, 4 of those things have a lot to do with reference data that I was just mentioning. Then I have another example similar to it that has to do with resistance management. So being able to rotate those active ingredients as you go along, right? And it also requires strict management of reference data. So what's the reference data problem? We collect all these massive amounts of data with farm equipment, drones, and so forth. A lot of that involves recording the amounts and types of products, whether they're chemicals or seeds or fertilizers, on fields. These data, like we said, are highly underutilized. People tend to not extract value from them. But why? Well, a very common problem is poor identification. Product 1, if you believe the controllers on the machines, product 1 is the most widely used product in the history of mechanized agriculture, right? And it often tends to get applied to field 1 also, right? The most intensively cultivated piece of land ever, right? And so if you didn't capture accurately what you applied and it comes back as product 1 or some very creatively spelled thing that your operator put in there, and you have to translate it into something that does make sense, that's not going to go well because growers hate doing that, especially if they look at these records at the end of the year. They don't remember what it was. They have to go pour through purchases from the retailer and so forth. That's very, very hard. It's completely unsustainable. So while some of these are workflow problems, which we'll discuss later, many of them are also the result of poor reference data. Enter TC347's ad hoc group 2, soon to be working group 1, hopefully. Our convener is Stuart Ray. Stuart, could you please stand? So that is Stuart. He is a very patient man. He has led a group of feral cats to the point where they have come up with a very nice draft standard for how we can manage reference data. Not reference data in general, that's coming soon, but crops in particular. The definition of what a crop is seemed to be like a really good place to start, right? Because maybe your machine knows it as corn, or corn, comma, yellow, or maize, right? But the farmer might also be thinking of a crop in terms of my yellow flint corn that I'm growing under irrigation, right? And the distinction is important because whether it's irrigated or not, for example, makes all the difference on how you're going to insure it and so forth, right? So the idea of capturing a crop accurately is quite tricky, and it's in the eyes of the beholder. If you're in the US, you typically think of this in terms of like 3 dimensions maybe, like the botanical part, the fact that it's corn, another part with, you know, intended use, where you might say, is this seed corn, is this grain corn, is this, you know, am I growing this for silage, what am I doing? And the third one might be some refinements like this flint, you know, organic, irrigated. If you're in, say, Japan, they have all these other dimensions that they care about for many of their crops. So this might be a burdock root that you have planted at this time of year with the intent of harvesting at this other time of year, and you're managing it so that you can harvest the root as opposed to like the shoots, right? That's like 7 dimensions. And so we're working on a model that allows you to pack as much meaning as you need. And crops were a great leading case. If you want to find out more, Stuart will talk about all this tomorrow at 3:50 p.m. in technical session 9. And there he'll tell us more about a series of standards that will follow crops that have to do with field operations, phenological stages, modes of action, active ingredients, and so forth. And we're also working on units of measure work. Second, agreeing on the resources involved. Here, it's useful to think in terms of something novel and interesting, like autonomy, right? Autonomous operation. Might want to do this to reduce your dependency on human labor, or because you have this extremely high-value crop and you want to harvest it when it's perfectly ripe, or for whatever reason. There's opportunities for standardization galore here, right? Like coming up with a standardized way of separating and coordinating between driving the vehicle, detecting the need for action, performing the operation, evaluating the result. And there's a lot of interesting work happening there. But you know what? Accurate field boundaries and making sure that what you think is in latitude and longitude such and such is really there is an important part of this as well. Boundaries matter. If your sprayer thinks the boundary is over there, but it's really there, somebody's not going to be happy, right? And trouble ensues. And why would this happen? Well, if you pulled your boundary data from Google Earth and you're trying to have a sprayer run section control with that boundary, bad things are going to happen, right? There's a data quality aspect to this that we have really paid very little attention to in agriculture over the last several decades. So let's talk about that a little more. We capture harvest data or as applied data or as planted data in these little chunks, and they, as part of larger blocks that may fall completely within a field, or depending on how you're doing your operation, you might drive across field boundaries. And you have to be able to deal out the spatial data so it falls in the right field so that you can do things like accrue production costs, right? And you need the quality of that boundary to be good. Then you need to think about where the boundary came from. And if it has things like bow ties and stuff like that that can make algorithms blow up, right? And different uses require different levels of accuracy and precision. So maybe something that you drew on Google Earth is fine to represent the idea of, field 1 in your farm management information system. But if you're trying to control your spraying operation with it, then that's not so good. Whereas the opposite, if you captured that on a four-wheeler with a real-time kinematic GNSS system that had been carefully calibrated, then you can use that boundary for many things. Maybe not for all things, because it might have so many points that rendering it might be very slow. So, you've got these interesting trade-offs. But the thing is that geographic metadata, like data quality, aspects of positioning, are very underutilized as well. So we talked about this active ingredient load thing. Well, good master data is required in several of those points, not just reference data, but good master data as well. And here, I'd like to point out that Ben Craker was supposed to be here. Are you here, Ben? Not yet. Well, he is working with Ad Hoc Group 10 on a data model for how to represent field boundaries as the also leading case for master data management. They're supporting a wide set of use cases. They look to also enable representing the provenance and fitness for use of a field boundary, which is something that we haven't had before, and is very industry friendly, just like the Ad Hoc Group 2 work. To find out more about this, the second talk tomorrow in technical session 9 is the place to go. 3, agreeing on how things happen. 4 quick use cases. Supporting a landscape sale with records of product applications and soil tests to prove that this land hasn't been mined for nutrients, right? Or provide evidence that you are leaving it better than you found it. Create pesticide use reports or calculate sustainable production or carbon intensity metrics, or our previous active ingredient load example. All of these things have some things in common. They require a record of what was done, where it was done, when it was done, who did it, why they did it, and how it was done, with what equipment, rates, and so forth. This includes different combinations of a set of documents that we'll see here in a moment. So imagine the producer is here in the middle, right? Early in the season, or before the season begins, they have like a strategic document, like a production plan, saying this is how I think we're going to produce the crop this season. Then shares that with the crop scout, advisor, and then the cycle kicks off of informing the decision by taking observations and measurements and past work records and giving those to the advisor, who comes up with recommendations that the decision maker then turns into work orders that turn into actual work that's then recorded, because what was actually done isn't always what you planned. Reality has a way to change the best plans, and then you can evaluate what happened. This is sort of a general model of the documentation cycle. Admittedly, there's as many versions and levels of detail of this as there are farmers on the planet, right? But this is a good sort of comprehensive way of looking at it. Maybe 3 of these documents live in the farmer's head, and the other 2 in a little a notebook in their pocket, or maybe these things are part of a big corporate IT system, right? And everything in between. Of course, these different cycles happen during the season in multiple places at different parts when you're planning or doing like IPM prevention or planting or taking care of your crop. You've got multiple iterations of all these things. Back to the use case, again, there's multiple places we're keeping track of what happened, right? And what it was motivated by, and therefore you've got your field operations data. This group is led by Patricia Perez out of Spain and Connie Graumans out of the Netherlands. And they're doing a great job on a data model that's backward compatible with 11783 Part 10, backward compatible with Ag Gateway's ADAPT, and based largely on it. Again, very industry friendly, and also allowing you to package a selection of records into what's called a field passport for exchange with other parties. Finally, agreeing on how to use what we know. The problem here is we collect, again, you'll see the theme here, massive amounts of data with farm equipment, drones, and so forth. Intuitively, we know that this stuff is valuable, right? But farmers have difficulty using those data to create value. The syntactic interoperability that Ad Hoc Group 8 is dealing with is an obstacle. The semantic interoperability that Ad Hoc Group 2 is dealing with also has a place in this, but there's more. Fact is that users are being set up to fail, not on purpose, right? But they're set up to fail as an emergent property of the way that things are set up. It's hard to know what data you need for solving a given problem. It's hard to know how good those data have to be, if you're collecting them properly or not. It's hard to know how to orchestrate it to get it to the right place at the right time and the right format and with the right code lists so that you can use it. And nobody explains this in a straightforward, actionable way, either to the grower or to their advisors, right? The literature doesn't have this, hey, look at this big picture. Start here, and these are all the steps that you need to follow to be successful, right? Because we all focus on the little parts that each one of us does, right? So there's all these, just in getting a work order or prescription out to the machine and bringing the data back, there's all these different pain points. And I won't go into detail with them, but they have to do with what's in the work order, and was I able to get it out to where I meant to, and did I have the codes in there for the products and the field boundaries and everything I needed, so that when I do the work and I bring it back, my farm management information system can recognize the products and the fields and so forth. And am I set up to be able to handle some kind of hot mix when things changed in the field? Do I know what to do if I ran out of this product and I have to change it for another, right? I showed you this wheel earlier, right, with those things. So we put, working with Kale, we put those pain points on this wheel. And spoiler alert for tomorrow, we concluded that there's another phase, which is this planning and workflow provisioning, which really addresses these things and can set you up for success, right? And this is the rather ambitious plan that he's got for a series of Ad Hoc Group 7 products and products from the other ad hoc groups to enable this decision making to happen. We'll talk more about this tomorrow as well, right? So our ad hoc group 7 is convened by Cale Boriak and Ben Kraker, and there's Cale, and I will applaud you because you have got quite the burden. And they're working on a series of drafts. So a draft for a workflow provisioning standard, a draft for a metadata collection standard to sort of work your way back from having the decision to knowing what variables go into that decision, to knowing what data do I need to go fetch and orchestrate that, and how complete those data sets need to be and how much time I need and so forth. Be able to codify that in a way that, that you can automate it, right? So you will find out more about this tomorrow. In closing, back to the strategy map. The 4 streams that I described above, they correspond to strategic objectives that in turn enable almost everything else above them on the stack. These early efforts, coupled with strong work on the lower strata, so getting ourselves set up so that our experts know what they're doing, they learn how to write requirements and so forth, and that we get our communications and stakeholder engagement and so forth working properly, should yield industry, academia, and regulator-friendly solutions to problems that we've had plaguing us for decades. So what are we trying to do? Well, we're trying to unlock scale, so enable scalable solutions to complex agri-food systems problems. So things that you can do beyond just a pilot, right? We're trying to reduce friction across the industry and prevent that tech debt for startups that usually brings them to fly into the ground, where they have reinvented so many wheels that they just can't sort of scale those solutions. Enable repeatable value creation, so technologists worldwide can develop decision support and workflow management tools on top of a stack of standards that can make that less soul crushing than it otherwise is starting from scratch. And we want to set farmers and other users up to succeed in data-driven decision-making and value-creating workflows. And that is the hope part of the story. How can you participate? The easy answer is ask Jean. Jean, are you here? Jean, she ran away. Okay, Jean Walsh knows all the answers to these things, right? She's the administrator of the U.S. Mirror Committee, or U.S. TAG as it's known, right? So we have another session tomorrow, as I've said multiple times. It's at 3:45, Medallion A. We'll go into more detail on these vignettes that we saw, right? And we've got all these different places where you can learn more. All right, and with that, thank you very much.
Thank you, Andres. As I said, we're recording this, so if you have questions, I will be glad to give you a microphone, and I'll start with one. You're talking about data for inputs for agri-food systems, and you talk about tracking those. Does your scope include the inputs to the equipment at this time, such as whether you're putting kilowatts into a battery or BTUs into a fuel tank, or whatever you're putting in? Are you looking at the equipment inputs also, or are you trying to manage your scope by staying on the food side only?
That's a tricky question. We need to be close to the equipment because there's a lot of very important information that's produced by the equipment, both the agronomic information and also the logistics information that Randy mentioned earlier today, right? Regarding the data that goes into the equipment manufacturing and management of the equipment itself, right? That one's a little bit fuzzier. The Strategic Advisory Group for Smart Farming had an OEM subgroup that asked itself those kinds of things. And unfortunately, it didn't come to clear conclusions, partly just because of the leadership of that particular subgroup. They couldn't sort of facilitate their way out of a wet paper bag. So we're going to work with the corresponding committees from TC23 to see what they need. If they want to work together, that's great.
Hey, Andres, I firmly believe that you've got to manage your scope well. I'm convinced that I can make the scope of any project so large I'm guaranteed failure.
And in this case, the ISO Technical Management Board asked us to keep the scope huge that way because they said the moment that you say, for example, no, we're not going to work with food, feed, fiber, fuel, and specialty crops. We're only going to work with this subset. They said, well, that moment you just created this huge artificial data interoperability barrier. So, and they're right. So that's why the scope is so big. What will get done depends on, in great part, on who shows up, Rusty. That standards work is always that way. You see, what happens? Well, it depends on who shows up willing to work.
Oh, can you hear me? Okay, good. So I was wondering, is this going to be openly available? If we're trying to create standards and definitions that we want everyone to use, are we going to be able to go to an agronomist and point them, hey, use these definitions, talk about it this way, this is how we should define field boundaries, this is the terminology. Startups anywhere in the world, are they going to be able to use the same terms so we're not having to constantly re-educate as they try an interoperable process? How's that going to work?
There's two dimensions to that. One is the management of frequently changing versus infrequently changing parts of standards. And the other one is the business model of standards development organizations, right? So standards have infrequently changing things. So that's the, sort of the general way in which you're doing something that you're documenting in a standard. And then they have frequently changing things like code lists when you're adding stuff, right? Where you have, say, a standard for environmental variables and you say, okay, today I have air temperature, but tomorrow I want to have, air temperature in the boundary layer, right? And then you say, oh, I need another variable. So you want to add it to the list. Typically, the way that the frequently changing stuff is managed is through what's called the maintenance agency, right? And so those, in the cases that we've dealt with, those schemas and code lists and so forth are freely available. So implementers can keep up with that stuff easily, right? Regarding the standards themselves, usually you need an act of God to make a standard freely available because for different organizations, especially the national standards bodies, a sizable fraction of their income comes from the sale of the standards, right? So to make a standard freely available requires sort of going against the grain of how the whole system is funded, right? We're exploring the opportunities that we have because some standards end up being free. We're trying to understand what the process needs to be. And what I've heard lately is, well, can you find somebody that has money? So if they can, put down some funding to make standard so-and-so freely available, then ISO will do it, right? I hope that answered.
So the idea is that we will try and find some way to at least get a subset that we can use for general discussion or so?
Yes,
Okay.
and I think that is actually good for business, for the standards development organizations. I guess it's like drugs. Like you give them the starter pack, and they say, "Oh man, this is awesome," and then you say, "Okay, give me the good stuff," and then you say, "Well, that's going to cost you, right?" But the value proposition has already been made clear, right? I don't think this is what Rusty had in mind when he imagined this lecture.
Andreas,
Yes, sir.
everything goes back to data quality. And it starts for us folks who are in the test world or have been in testing, calibration of data going in is the critical part. I don't think you would find a test engineer around here would say raw data coming in from our sensors today is good enough. Is that somehow captured in the standards work?
Yes, that's very important, right? And usually there isn't very clear workflows documented for the end user on why this is important. Where's the value in having good data, right? What constitutes good data? Why is it valuable? That isn't very clear to the end user. Technical Committee 211, decades ago, the GIS people, so Geographic Information and Geomatics, they came up with a very elegant suite of standards for geographic information, like ISO 19156 for observations and measurements, 19157 for data quality, 19115 for metadata. We're drawing from all of those because that framework's already there. So we know how to represent data quality metrics and data quality elements, right? It's just that we need to show how this can work in agriculture and communicate the value of it. So that's why that near obsessive emphasis on workflow management and logistics. I forgot to mention that. That's something else that Kale believes, that if you squint just right, everything is like a logistics problem, even with data, right? So yes, you're absolutely right that data quality is at the heart of it all. Data quality is tricky though, because it lies in the eyes of the beholder and what you're trying to do. A data set might be terrible for some applications and fine for another, right? Your terribly miscalibrated yield map might be really bad for trying to estimate how much you pulled from that field, but it might be great if the XYZ offsets were properly captured. Might be great for seeing what your harvested area was, right? So it all depends.
Yield maps are great for relative yield, but it's terrible for absolute, in my opinion, and I'm part of the problem.
Any other questions? Anyone? No?
Just warming up.
Thanks, Andres. Great presentation. Just had a quick question. You were talking about AHG2 that Stuart's been working on. Stuart, this may be a question I should be asking you, but you were noting that products are often poorly identified. And I wrote down field identification's too tedious. We have, crop type 1, field 1, blah, blah, blah. And Stuart's been working on HG2, which enables us to incorporate as much data as are needed to identify things. Correct me if I'm stating that incorrectly, but
There's two things there.
yeah, go ahead.
There's two things there, and I will hand one of them off to Stuart. So there's the part about entering data in the field, right, which is really bad. Like having a guy creatively spell with his fat finger on a membrane keyboard the name of a pesticide that ends in XL plus Ultra Max, right? Where a lot of the AI information, the active ingredient information is at the end of that name. And to do that in a 16 or 26 or 32 character display, right, is a losing proposition, right? And so you end up with something that came in some blob, right? And somebody then has to say, what was it that, you know, Billy actually entered? I don't know, Billy doesn't work here anymore, right? And so that's terrible, right? And it has to be avoided. And the way that you do that is by sending these things out to the cab to begin with, preferably in a neatly packaged task already there, where the guy just has to say start, right? But allowing them to be able to make changes with something that they can pick from the drop down because you already sent it out too, right? But that only works if you have made them owners of the value proposition, and by them I mean like the operator. If the operator's invested in the value of this workflow that's meant to create value, right? So that's the first part. For the second part, we call that a componentized model of semantic resources, and I'll throw that one over to Stuart.
Right, so the general idea here is that a lot of the vocabularies that we use in agriculture end up being multiple things commingled at once, right? So you look at a common crop list and you have, you know, potatoes for chips, potatoes for processing, potatoes for starch. Well, okay, the common, you know, genetic anchor there is the fact that it's the potato, but then you have intended use bound in that list. And that creates problems downstream when you do things like that. So our hypothesis that we're working through proving out here is that a lot of controlled vocabularies in ag can be decomposed into a componentized model where each category of components are orthogonal, right? And you can take something like hard red winter wheat, and you can decompose that into a category that has to do with its genetic meaning, the wheat, and then these other orthogonal categories like the hard, the red, and the winter. And you can manage those separately, and together they end up forming the meaning of a concept when you combine them together. And so Ad Hoc Group 2 started with crop because it's the one that's kind of ubiquitous. It's everywhere, right? And we use it based on context. We talk about crop as what we pulled off the field. We talk about crop as how we search for seeds. We talk about crop as, you know, we're insuring. And all of those have subtly different meanings, but we use the term crop the same way. And each usage of those has different kind of a spectrum of specificity that are needed for the situations it's used in. So, you know, you want to know more, come listen to us tomorrow. Please come participate, you know, see Gene. Okay, Ad Hoc Group 2 has just turned in our working draft for crop. We are going to, I think, move to field agricultural activities next, right? And field operations. And then hopefully circle back to a general theory of everything about how we have a framework of decomposing these things on a regular basis. Sorry to hijack your time there.
Thank you. I mentioned Stuart and Kale and Ben as people you can go ask about these things because they're leading some work. I also want to point out and throw under the bus Asahiko Yamada, who is the administrator of the Japanese delegation to TC 347. Could you stand up, please, for a moment? Let's look at him well, because he goes to a lot of these different ad hoc group meetings, right, as a participant, right? So you can ask him what it's, if it really is like drinking from a fire hose, as this might seem, and, you know, what the mechanisms for participation are and what that all looks like. I think he's a perfect guy to ask. Thank you.
Any more questions? Okay, just a second, please. Andres, on behalf of ASABE and the Ag Equipment Technology Conference 2026, we appreciate the distinguished lecture. Thank you.
Thank you. Thank you so much.
Thank you. We'll get a picture with you.
Okay.
Thank you, everyone. Thank you for attending this evening. Let's make our way to the Connect and Mingle now. So, and we'll see you later. Thank you. The lecture.